A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So, Daniel sent us this one, and it's a question I think a lot of developers are quietly wrestling with right now. He's asking us to compare code-defined agentic workflow builders against visual programming ones. Tools like LangGraph and CrewAI on one side, Fluise and A10 on the other, and crucially, he's framing it for a developer audience. Code literacy is not the constraint here. The question is purely strategic. Given that you can write the code, why would you ever choose not to? And what do you actually lose when you hand the reins to a visual canvas?
Herman Poppleberry, by the way, for anyone new here. And yeah, this is a question that has a surprisingly non-obvious answer. Because the instinct for most developers is to dismiss visual builders immediately. That's for non-programmers, I'll just write LangGraph. And I think that instinct is both understandable and slightly wrong.
Slightly wrong is doing a lot of work in that sentence.
It is. Because there are genuine, non-trivial things you get from visual builders even as a developer, but there are also genuine, non-trivial things you lose. And I think the honest answer is that the trade-offs are more context-dependent than either camp usually admits.
Also, quick note before we dive in. Today's script is powered by Claude Sonnet 4.6, our friendly AI collaborator. Alright, let's set the stage. What does the current landscape actually look like? Because it's crystallized quite a bit recently.
It really has. You've got two fairly distinct camps. On the visual side, Fluise, Langflow, N8Neen, BotPress Rivet. On the code-first side, LangGraph, CrewAI, AutoGen, Small Agents, the broader LangChain ecosystem, and now OpenAI's AgentKit. And then there's a hybrid middle ground that's genuinely interesting. 8N with its JavaScript code nodes, Langflow where components are actually Python classes, CrewAI Studio, which is a visual UI sitting on top of pure Python. That hybrid category is where a lot of the nuance lives.
The market context is also kind of staggering. The no-code AI platform market is projected to go from around $4.7 billion to nearly $38 billion by 2033. That's a 29% compound annual growth rate. So whatever developers think about visual tools, enterprises are clearly not dismissing them.
And Gartner was predicting that 70% of new enterprise applications would use no-code technologies by this year. Whether that number has held up exactly, the directional signal is clear.
Okay, so let's start with the gains. Because I think this is where developers most often shortchange the analysis. What does a visual builder actually give you that's genuinely hard to replicate in code?
The first one is prototyping speed, and it's more significant than it sounds. BotPress can get a working chatbot template deployed in under 15 minutes. What takes 30 minutes on a no-code platform can legitimately take days in code. Environment setup, boilerplate, wiring up integrations. For proof-of-concept work where you're trying to validate an idea before committing to an architecture, that speed asymmetry is a real competitive advantage.
Though I'd push back slightly. If you're a developer who's already done that boilerplate 10 times, your baseline is much faster than a first-timer's.
True, but the second point is harder to dismiss. Integration libraries. N8N has over 400 pre-built connectors. Slack, Postgres, Pinecone, Qdrant, Google Drive, and on and on. Building those integrations from scratch isn't just boilerplate, it's auth flows, pagination, API versioning, error handling, rate limiting. The visual tool has already solved all of that. And for an agent that needs to touch 15 different services, that's not trivial.
That's actually the one that gets me, because I can write Python. But do I want to spend 3 days getting Salesforce's OAuth flow working correctly when 18 has a Salesforce node that just works?
And this connects to the third gain, built-in operational infrastructure. run history, retry logic, scheduling, webhooks. And ADN's run logs are genuinely considered best in class. This is non-trivial infrastructure that you'd have to build yourself in a code-first framework. When your agent fails at 2 in the morning, having a visual run history that shows you exactly where it broke is genuinely valuable.
Okay, so there's a real case here. What about the debugging experience? Because I've heard interesting things about Rivet specifically.
Rivet is fascinating for this reason. It was designed specifically for real-time visibility into inputs, outputs, and AI responses as they flow through the graph. You can watch the agent's reasoning unfold node by node in real time. That's a qualitatively different debugging experience than adding print statements to a LangGraph script and reading log output. Flowiz has a similar chatflow debugger. For understanding what an LLM-based pipeline is actually doing, the visual representation can be genuinely illuminating.
And there's a collaboration angle here too, right? Even if you're the developer, you might have a product manager or a domain expert who needs to understand the workflow.
The visual artifact serves as living documentation. You could walk a non-technical stakeholder through a workflow on a canvas in a way that's genuinely impossible with a Python file. And if they can suggest changes, what if we add a validation step here? That feedback loop is much tighter when they can see the structure. That's a real organizational benefit, not just a nice to have.
Alright, I'm convinced there's a case for visual builders that isn't just, it's for people who can't code. Now let's get into what you actually lose, because I suspect this is where the more interesting tensions are.
The biggest one, and it's cited consistently by developers who've been burned, version control. Visual workflows are stored as JSON, or sometimes binary formats. Git diffs on a JSON node graph are essentially unreadable. You can't do meaningful code review on a pull request for a visual workflow. There's a Hacker News thread from 2019 on visual programming that's still completely relevant. Developers calling this a fundamental problem, saying it has no effective means of versioning, diffing, or merging. Ann8n does let you back up workflows to GitHub, but the diffs are JSON blobs, not human-readable logic. You can't look at a pull request and understand what actually changed in the agent's behavior.
And for any team doing serious software development, code review isn't optional. It's how you catch bugs, share knowledge, and maintain quality. If you can't review it meaningfully, you've got a blind spot in your process.
Which connects to the second major loss, unit testing and CI/CD integration. Code-first frameworks can be tested with PyTest, integrated into GitHub Actions, subjected to automated regression testing. Visual workflows have no equivalent. You can't write a test that says, given this input, the agent should call this tool with these parameters. Harrison Chase from LangChain made this point in February. Agents are non-deterministic systems, so you have no idea what inputs or outputs to expect until you ship. That's exactly why testing and monitoring are critical, and visual tools make that testing story much harder.
The non-determinism point is interesting because it cuts in a complicated direction. If agents are inherently non-deterministic, does testability matter less?
It's actually the opposite. Because agents are non-deterministic, you need more rigorous testing infrastructure, not less. You need to be able to run a suite of test cases and verify that the agent's behavior falls within acceptable bounds across a distribution of inputs. LangGraph integrates with Langsmith for exactly this. You could build eval datasets, run regression tests, track performance over time. That's a production engineering capability that visual tools largely don't have.
Okay, so testing is a real gap. What about the scaling problem? Because I feel like this is where the 40-year history of visual programming is instructive.
This is the one that keeps coming up in developer discussions, and it's genuinely unsolved. The spaghetti problem. LabVIEW, Unreal Blueprints, Max MSP, developers have been wrestling with this since the 1980s. Visual workflows are intuitive for small examples, but as they grow, the two-dimensional canvas becomes a tangle of crossing lines. There's no equivalent of extract function or rename variable. You can't refactor a visual workflow the way you'd refactor code. One developer in that HN thread put it well. A lot of production visual programming diagrams are spaghetti code, without comments or a changelog you can study. And importantly, there's no mechanism for abstraction and reuse. In code, you write a function once and call it from 10 places. In a visual tool, you often duplicate the logic.
So the easy start becomes a hard maintenance trap, which is almost the inverse of code, where the start can be harder, but the long-term maintainability story is much better.
And there's a subtler point here that I find interesting. Visual tools may actually require more upfront planning than code, not less. In code, you can write something messy and refactor it later. In a visual workflow, restructuring a complex graph is genuinely painful. The perceived accessibility of the visual canvas can lead developers to dive in without thinking through the architecture, and then they're stuck with a structure that's hard to change.
That's a bit of a paradox, isn't it? The thing that's supposed to be more approachable ends up punishing you more for not thinking it through first.
It really is. Now, the third major loss is one that I think is underappreciated specifically in the current moment, AI-assisted development. You can use GitHub Copilot, Claude Code, or Cursor to help you write LangGraph or Crew AI code. You cannot use them to build 8N or Flowys workflows. The visual canvas is opaque to AI coding assistance. For a developer who relies on AI-assisted coding, and that's increasingly most developers, this is a significant productivity asymmetry. You can vibe code a LangGraph agent. You fundamentally cannot vibe build a visual workflow in the same way.
That's actually a counterintuitive reversal. The visual tool is supposed to be more accessible, but you've lost access to the most powerful productivity tool in a developer's current arsenal.
And it's a 2026 specific insight that most of the older comparisons between visual and code tools completely miss. The calculus has shifted because AI coding assistance has become so central to how developers actually work.
Let's talk about the determinism question, because there's a really interesting tension here. Which approach actually gives you more control over what your agent does?
This is where it gets nuanced. The Aiton analysis from Andrew Green makes a provocative point. Most people building agentic workflows prefer to nudge an agent 20 times to get a response they want, rather than putting work up front into defining deterministic logic. And he's not wrong that this is the dominant pattern in practice. But LangGraph's explicit state machine architecture gives you something genuinely different. You can define guaranteed execution paths. You can enforce that an agent always performs a specific check before proceeding, regardless of what the LLM wants to do. Visual tools can represent deterministic steps visually, but they can also obscure whether a given step is truly deterministic or LLM-driven because they look the same on the canvas.
So the visual representation can actually create false confidence about what's guaranteed versus what's probabilistic.
That's a real risk. And for compliance-critical use cases, healthcare, finance, anything where you need to demonstrate that a specific control was applied, that ambiguity is a serious problem. Which brings us to the enterprise readiness gap. Code-first frameworks give you full control over role-based access control, audit logging, data loss prevention, custom compliance controls. Visual tools rely on the platform's built-in governance, which may or may not meet your requirements. The A10 analysis specifically calls out what they call enterprisiness as the key differentiator now. Observability, data loss prevention, transparency, proxy-based filtering, authentication, agent identity, lineage, rollback, and code sandboxing. For regulated industries, this gap is often decisive.
And the vendor lock-in story for visual tools is particularly gnarly, right? Because it's not just one layer.
Kai Wayner's enterprise AI landscape analysis from April makes a point. I find genuinely alarming agentic AI lock-in is more durable than API lock-in because it accumulates at multiple layers simultaneously. The foundation model, the orchestration framework, the runtime environment, and the developer patterns the teams build around them. Visual tools add another layer on top of all of that, the workflow format itself. Migrating from Flowys to 8N or from 8N to LangGraph isn't a refactor, it's a rebuild. And for a developer building something that's going to be in production for 3 to 5 years, that's a strategic risk that deserves explicit consideration.
The Flowys acquisition by Workday is interesting in that context, because suddenly, your open source tool has an enterprise parent with its own roadmap and priorities.
That's a real signal about where the market is going. Enterprise consolidation in the visual builder space, which means the vendor lock-in risk is not theoretical. Your visual tool's future is increasingly tied to decisions made by a large company whose interests may not align with yours.
Let's talk about the observability story, because Harrison Chase had an insight here that I think reframes the whole debate.
This is one of my favorite conceptual shifts in the whole space. Chase's point is that in traditional software, the code documents the application. You read the code to understand what the system does. In agentic AI, the traces document the application. Because agents are non-deterministic, the code defines the structure, but the actual behavior is documented in execution traces. What the agent actually did, what tools it called, what it reasoned about, that lives in the traces, not the code.
Which is a bit disorienting if you're coming from traditional software development. The thing you're used to relying on for understanding. The code is less informative than you'd expect.
And it cuts in an interesting direction for this debate. It partially diminishes the readability advantage of code-first frameworks. But, and this is important, code-first frameworks have significantly better trace tooling. LangGraph integrates natively with Langsmith and Langfuse for deep observability, token-by-token streaming, full trace trees, eval datasets, regression testing. Visual tools have built-in monitoring, but it's typically less granular. So the insight that traces matter more than code doesn't make visual tools better. It actually raises the bar for observability tooling, which code-first frameworks currently do better.
So you need both good code and good traces. And right now, the code-first ecosystem has the better trace infrastructure.
That's the current state of it. Though to be fair, this is a fast-moving area. The commoditization trend is worth noting here. A lot of capabilities that differentiated tools in 2025 have become table stakes. RAG, Web Search, Memory Management, Basic Tool Calling. Every tool has these now. What differentiates tools currently is enterprise readiness, deterministic control, observability depth, integration breadth, and what the ADN analysis calls codability, the ability to define complex agentic logic in a framework that can grow with your requirements.
Alright, let's get into the hybrid middle ground, because I think dismissing it as worst of both worlds is too easy.
It's genuinely interesting. Langflow is probably the most code-friendly visual tool in the space. Its components are actual Python classes with typed inputs and outputs. You can customize any node by dropping into Python. Flows are exportable as JSON and deployable as REST APIs or MCP servers. The visual layer is a configuration interface, not a constraint. N8N is similar but different. Visual Canvas plus JavaScript code nodes, and it now supports MCP as both a client and a server, which means 8N workflows can be exposed as tools for code-first agents and vice versa. That interoperability is genuinely interesting.
The MCP angle is underrated, because it means the visual code divide is becoming less of a wall and more of a spectrum, where components from both worlds can talk to each other.
Rivet is worth calling out separately because it was designed for a specific problem, debugging AI prompt chains. It's a visual IDE with TypeScript libraries for execution. The visual layer exists to give you real-time visibility into what's happening in your prompt pipeline, while the TypeScript libraries give you code-level control over execution. For a developer who wants the debugging benefits of visual representation without giving up code control, Rivet is an interesting middle path.
So how do you actually decide? Because I think the honest answer is that this is use case dependent in ways that are more specific than most comparisons acknowledge.
Let me try to be concrete about this. If you're doing rapid prototyping, less than 2 weeks to a demo, primarily integration heavy work connecting SaaS tools and APIs, and you need non-technical stakeholders to understand the workflow, visual builders have a genuine edge. N8N's 400 plus connectors mean you're not writing OAuth flows. The built-in monitoring means you have operational infrastructure on day one. The visual artifact means your product manager can follow along.
And if you're below about 20 nodes of equivalent complexity, the spaghetti problem probably won't bite you.
That's a reasonable heuristic. On the other side, if you're building compliance-critical systems, if you need custom Python libraries that aren't available as nodes, if you need complex state management with guaranteed execution paths, if team collaboration via Git and code review is important, if you want AI coding assistants to help you build the thing, code first is the right choice. LangGraph scores 9 out of 10 for scalability and 10 out of 10 for customization in the framework ratings. Crew AI scores 8 across the board. Fluise scores 6 for both scalability and customization. Those numbers tell a story.
What about the leaky abstraction ceiling? Because I think this is where a lot of developers get burned. They start with a visual tool, get 90% of the way there, and then discover the tool can't do the last 10%.
This is the most important question to ask before you start. How quickly will you hit the ceiling? For a simple automation workflow, customer service chatbot, document Q&A, basic multi-step pipeline, you may never hit it. For a complex multi-agent system with custom tool chains, specialized data processing, non-standard state management, you'll hit it fast. And the painful part is that when you hit it, you don't get to refactor. You get to rebuild. The skill is accurately predicting, before you start building, which category your project falls into.
And that prediction is harder than it sounds, because requirements tend to grow.
This is actually the strongest argument for starting code first, even on projects that seem simple. The cost of migrating from a visual tool to a code-first framework is very high. You're not porting code, you're recreating logic from scratch. The cost of starting with LangGraph on a project that turns out to be simple is just a bit more boilerplate up front. The asymmetry of those costs favors code first as a default for production systems.
Unless speed to demo is genuinely existential for the project.
Right. If you need to show something working in a week to get funding or stakeholder buy-in, the prototyping speed of visual builders is worth the future migration risk, but that should be a deliberate, eyes-open choice, not a default.
What are the practical takeaways here for a developer who's actually making this decision right now?
A few things I'd keep front of mind. First, the AI coding assistant question is now a first-class consideration. If you and your team are using Copilot or Cursor or Claude Code heavily, and most teams are, that's a concrete productivity argument for code first that has nothing to do with the tool's intrinsic capabilities. You're choosing between a framework that your AI assistant can help you build and one it can't.
Second thing I'd add, be honest about your observability requirements before you start, not after. Because the trace tooling story for code-first frameworks, Langsmith, Langfuse, OpenTelemetry integration, is substantially more mature than what visual tools offer. And for production agentic systems, observability isn't optional.
Third, if you're in a regulated industry, the enterprise readiness gap is probably decisive right now. Not because visual tools can't eventually close it, but because they haven't yet. The audit logging, RBAC, compliance controls you need are much more straightforwardly implemented in code.
And fourth, which I think is the most underappreciated one, think carefully about the hybrid options before committing to either extreme. Langflow specifically is closer to a visual Python IDE than a traditional no-code tool. If you want the debugging visibility of a canvas and the flexibility of Python, it might be the right middle ground for a specific class of problems.
The MCP interoperability point matters here too. The emerging pattern where visual workflows can be exposed as tools for code-first agents, and vice versa, means you don't necessarily have to pick one paradigm for your entire system. You might use 8n for the integration-heavy parts and LangGraph for the parts that need complex state management, and have them talk to each other via MCP.
That's actually a pretty elegant architectural pattern. Use the right tool for each layer rather than forcing everything through one paradigm.
And that's probably where the industry is headed. The binary of visual versus code is already becoming less sharp as the hybrid tools mature and the MCP ecosystem grows. The question won't be which paradigm, but where on the spectrum for this specific component.
Alright, I think that's a genuinely useful map of the territory. The short version, visual builders have real, non-trivial advantages even for developers. Prototyping speed, integration breadth, debugging visibility, operational infrastructure. But the losses are also real and serious. Version control, testing, AI coding assistant support, scalability, vendor lock-in, observability depth. The decision should be use case specific and eyes open, not reflexive in either direction.
And the 40-year history of visual programming is worth taking seriously. The spaghetti problem is real, it's documented, and the AI agent space is not magically immune to it. The developers who've been burned by visual tools at scale in games, VFX, and scientific computing are telling you something important.
Big thanks to our producer Hilbert Flumingtop for keeping the whole operation running. And a genuine thank you to Modal for providing the GPU credits that make this show possible. If you haven't followed us on Spotify yet, search for My Weird Prompts and hit follow. It genuinely helps. This has been My Weird Prompts. We'll see you next time.
Take care, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth